So for question 9, let's assume our peptide has a molecular mass of 660 gram per mole. This is just simply something to work with, and I just made up this number. So question 9, you are looking for how many moles of the peptide did you get. So we are looking for the unit mole. Do we have mole anywhere? Yes, we've got that in the molecular mass. So we write it as mole divided by 660 gram. Now the mole is in the right position, but we need to get rid of the gram. So we multiply that by the number of milligrams that we have, so times 10 to the minus 3 gram, and the minus 3, that's our milligram. And the gram cancel out, and we have left 10 times 10 to the minus 3 divided by 660 mole. So that would be the number of moles in that you got from the company. Question 10 asks us how much of the peptide you need to dissolve. So we are looking for milligram. So milligram. We know that 1,000 milligram are in 1 gram. So let's write that down. 1,000 milligram per gram. So that's right. And so do we have milligram anywhere? Yes, we have 1,000 milligram per gram. So we've got the gram is in the right position. Now we need to get rid of the gram down here. So do we have any gram somewhere? Yes, we have our molecular mass. So times 660 gram per mole. So the gram cancel out. Now we need to get rid of the mole. Do we have mole in our questions anyway? Yes, we've got that here in the 100 micromolar. So 100 micromolar means times 100 times, and I'm running out of space here, 10 to the minus 6 mole per liter. So the mole cancels out, and now we need to get rid of the liter here. And it says here we need to prepare 2 milliliter. So we just multiply that times 2 times 10 to the minus 3 liter. Now the liter cancel out as well. So all we have left is now the unit milligram. And that was the unit that we want. And we can beautify that a little bit. So we can write this as, oops, that was not what I wanted. So we can write that as 1,000 times 660 times 100 times 10 to the minus 6 times 2 times 10 to the minus 3, and the unit would be milligram. And you can do, obviously, you can do the rest for that. So for question 11, we are looking at how much we have to dilute the sample from question 10. We still have our molecular mass of 660 gram per mole, which I just made up. So let's see how we can do that. So we have the added problem that we have a stock solution. So our stock is 100 micromolar, and our working solution is 0.001 milligram per milliliter. Or we can also just simply cancel the millis, 10 to the minus 3, we can cancel that, so that gives us a working solution of 0.001 gram per liter. Now let's convert this gram per liter into mole per liter. So we want to have mole per liter for that. So do we have a mole anywhere? Yeah, we have that up here in our molecular mass. So we have mole divided by 660 gram. Now the mole is in the right place, but we need to get rid of the grams. So we just simply multiply that by the grams that we have here in our solution. So that's this guy here. So times 0.001 gram per liter. And what we see, the gram cancel out, and we've got mole per liter. So we can beautify that a little bit. And our solution would be 0.001 over 660 mole per liter. So that gives us 1.52 times 10 to the minus 6 molar, or which is the same as 1.52 micromolar. Now we want to figure out what is the dilution, how we have to dilute that. And for the dilution factor, all we need to do is we divide the stock solution divided by the working solution. So we have 100 micromolar divided by 1.52 micromolar, and that gives us 66. So we need to dilute our stock solution by factor 66 in order to get our working solution. So for question 12, this is just simply a dilution of a solution. So we can use the equation C1V1 equals C2V2, and we are looking for the volume that we need from the stock solution. So the volume of the stock, so let's say that here is the stock, and that here is the working solution. So we are looking for the volume, you are looking for V1. V1 equals C2V2 divided by C1. And all we need to do is we need to plug in our numbers. So here we have C2, that is our working solution, 1.52 micromolar times, and we need 5.5 milliliters times 5.5 milliliters divided by 100 micromolar. That was the concentration of our stock solution, and that gives us 0.084 milliliter of the stock solution. And how much water do we need, or buffer do we need? So amount of solvent, let's just simply call it solvent. So this would be obviously 5.5 milliliter minus 0.084 milliliter. So that would be the volume of solvent. So if we add our stock solution, plus the solvent that we have, we would get a total of 5.5 milliliter, and that is exactly what we want. So I hope this makes sense, and thank you for watching.